Hey class, this is Mr. Roberts at Shasta High School, room 309, and I'm posting this because several students asked that I do this just so that they have an opportunity to review the procedure for finding a model for linear data, right? How do I find the least squares regression line? So this model, of course, will be in the form y equals mx plus b. And it's just a matter of using this data, right, to figure out what the optimal slope is and y-intercept that gives me the best line of fit, the least square regression line of fit. So one thing that I do suggest is it's possible that because other people do use these calculators, that some of the settings could get messed up. So anytime you get a calculator, pressing second and then O2 clears the memory perfectly, right? So it's a nice, easy thing, just second and then O2. It's like I'm breathing oxygen. Now that my calculator is completely clear, I can enter my data by pressing the button that says data, right? So I guess the first button I would press is data. And then after I press that data button, I'm going to enter my X values, right? You can see these are the X values. I'm going to enter them. So in this column, I'll enter the X values. The very first number I have there is 12. Oops, not that's 1, 12. And then I've got a 13.3. And then I've got 8.2. And then we have a 7, a 6, and finally a 9.1. So you can see I've entered 6 values and I'm down on the 7th line. Now I'm going to go over to list 2. And in list 2, I'm going to enter the corresponding y values. So it's very important that as I enter these, that the y's and x's go together. So we're entering the y's. Across from 12, I'm going to enter the number 20. Across from the 13.3 is 26. 8.2 is getting 15. The 7's getting 13. 6 is getting 13.2. And the 9.1 is 17.6. All right. Now that my data is entered, it's time to get the line of best fit. So to do that, I'm going to press the second button, and then I'm going to press, it's the data button, but it says stat, right? Stat. So it's on the same button as data. So you can see right here is second. I press second, and then I'm going to go to this button because it says stat, short for statistics. Boom. Because we have both x's and y, this is 2 variable stats. It's not 1 variable, but 2 variable stats. Every single event had 2 numbers. So we're going to go down to 2 variable stats and press enter. And this is just a quick verification. It's asking, hey, did you enter your x's in list 1? I did. Did you enter your y values in list 2? I did. So I can go down, I can press enter, enter, and then I can press enter on calc. What I want to do is scroll down to a capital D, right? Capital D and an ABC and also capital E. So on capital D, when I go down here, you can see 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I can see A, B, C. There's the capital D and there's the capital E. So on line D of this list, it tells me that A is equal to 1.67. So if I was rounding to the nearest hundredth, right, I would write 1.67. That turns out to be my slope. That is the slope of the line of best fit. And the y-intercept for the line of best fit is B, and B is 1.99 in this case if I rounded to the nearest hundredth. So from these two boxes, I can see both the slope, that's going to be A, and I can see the y-intercept, that will be stored in B, of my line of best fit. So I'll write the equation of the line of best fit. It is y is equal to my slope is 1.67 times x plus 1.99. There it is. The other thing that I can see on this is the correlation coefficient. And I didn't point it out, but let me go up to that. The correlation coefficient lives, where is it at? Oh, I guess it's the correlation coefficient is past D. So I'll go down to A, B, C, D, E. Oh, there it is. It's on line F. Okay, so on line F, we can see our correlation coefficient R And in this case, R is 0.9, well, I guess 0.96 if I was rounding to the nearest hundredths also. So very strong association between these two variables, right, at 0.96. So I see pretty much everything I need to. Now, one of the things we did talk about in class, especially periods 4 and period 6, was how do I find a residual for one of these points, right? All of these points in my data set have residuals, and that just means that there's a difference between what the model predicts and what value is recorded for y in the data set. So let's look at the residual for this particular point, right? If I had a sketch of the graph, somewhere there's an x value, and that x value goes up to 13. That's the actual value that we recorded in our data set, right? Or from our observational study, from our experiment, we recorded an actual y value of 13. Now, my model is used to predict y values. That's the purpose of the model. If I give the model certain x values, right, it will tell me the predicted y for that x. So you can see, here's my model, and I know that my actual y, I'll just call this y actual. The actual y is 13. That's observed in my data set. And the y value that is predicted when x is 7, right? So again, we're talking about when x is the number 7. When x is the number 7, the actual y was 13. The predicted y is the number that I get when I go, let's see, I'm going to go 1.6, oh, let me clear this, 1.67. Oh, no, I don't want to put this in line 2. That's going to mess all that up. Let me just hit second quit. There we go. So I'll hit 1.67 times x is equal to 7, and then plus 1.99. So what happens is I get a y value that's predicted to be 13.68. So you can see we have both our actual y and our predicted y, and our residual, right, is the difference between those two numbers. The residual is always equal to the actual y minus the predicted y. So I'm looking at 13 minus 13.68. So the residual for this point, right, I would say 7 comma 13 has a residual of, what is it, 0.68. 0.68. Okay. So again, the point here is I just wanted to review how is it that we set out to find our, how do we set out to find our, how do we set out to find the correlation coefficient? How do we find our least square regression line? And then if we're asked for some residuals, how do we find a particular residual? So this is definitely a strong association between these two variables. Correlation coefficient was 0.96. The other thing I could do is like, I can plug in like, hey, my data set didn't have any point where x was 10. So I can say, hey, well, what do I think will happen at 10? What do I think is the predicted value for 10? And I could just plug that in. I can say, look, my model predicts that if x is 10, what's it going to be? 16.7 plus 1.99. So you can see those things. And I'm not entirely sure, but I think actually if I hit table, nope. I thought maybe it would have that automatically recorded, but it doesn't. But I could enter that. I could say, hey, I could say 1.67 times x plus 1.99. So if I had to do a lot of predictions, I might do this. Right now, this is going to be start at 0, step by 1, and I'll just do auto. So what this does now is it says for this particular model, right, you can see here, and it says that x, when x is 10, you're going to get a predicted value of 18.69. And check this out, at 7, right, we knew this already, when x is 7, the model predicts that you're going to get 13.68. So anyways, that's kind of the steps how we can use the classroom calculators to pretty easily find a line of best fit, and then make some predictions, figure out our correlation coefficient, and calculate some residuals. That's it. I hope you found that helpful. This is Mr. Roberts. Talk to you later.